Significant digits. An interesting concept, good in theory, but you may look at them and think, when am I ever going to need to know this? But here, in a simulation relatable to every single child in the world, I will show you the significance of significant digits. Let's say you're getting ready for Halloween, right? I know Halloween's in a few weeks for us. You unwrap your Reese's Peanut Butter Cup. A beauty with chocolate and peanut butter. But before you eat it, let's say your annoying kid sister walks into the room and she really wants half. So you decide, fine, I'll split it in half. I'll be a good person. You start off with one Reese's Cup. One digit. Cut it in half. So here we have 0.5 Reese's Cups, right? The thing is, how do we know that this is 0.5 and 0.5 and not 0.6 and 0.4 or 0.52 and 0.48? Your math teachers have lied to you. They've always told you that 0.5 is the same as 0.500 and 0.50000 and 0.5000000 forever. When dealing with significant digits, that's not always the case. 1 divided by 2. It's simple math, 0.5. But let's look at it again. When multiplying and dividing numbers with significant digits, you have to pay attention to how many digits are in each number that you're multiplying or dividing. For example, 1.00 divided by 2.0. Your answer is going to be 0.50. Why is that? Because you need two significant digits, because 2.0 has two significant digits. Your answer would not be 0.500, because that would have 3 digits, and the smallest number of digits you're multiplying or dividing by is 2. Even though they both mean 1/2, this way we know that we have exactly 0.5 and not 0.4 or 0.6. Now may be the part where you say to me, that's great and all, but I don't really know what a significant digit is, and can I eat that Reese's Cup? I'll answer your second question first. No, but I can. Significant digits are numbers we use in measurement. Non-zero numbers are always significant, so anytime you see a number between 1 and 9, you know it's significant. If you have 22.3, 3 significant digits. Zeros are more complicated. Zeros before other digits are not significant. So for example, 0.046 only has 2 significant digits, the 4 and the 6. Zeros between significant digits are always significant. So 4009 has 4 significant digits. Zeros placed after other digits but behind a decimal point are significant. So 7.90 has 3 significant digits because in this case, the 0 after the decimal point, because it's also after a significant digit, is significant. Sounds confusing when you say it, but if you look at the rules, it's not that difficult. Zeros that are at the end of a number but not after a decimal point are not significant. Look at it this way. 7,900.00. So 7900.00. All the zeros are significant because the decimal point is there that tells you that it's exact. But if you just have 7,900, 7900, those 2 zeros are insignificant because all they're doing is filling the place for the 1s and 10s digit that isn't actually there. When adding and subtracting with significant digits, it's important to also pay attention to how many decimal places there are. Your answer will always have the same number of decimal places as the number you're adding or subtracting with the least number of decimal places. Here's an example. If I have 12.58 and I'm subtracting 11.6, my difference is going to have 1 decimal place because 11.6 only has 1 decimal place. If I had 12.8 and I was subtracting 11.52, my answer would still only have 1 decimal place, this time because the larger number only has 1. Multiplying and dividing works basically the same way, except that instead of looking at how many decimal places your numbers have, you're looking at how many significant digits they contain. Here's an example. Let's say I have 1.587 liters, and I'm multiplying it by 3.2. My answer is only going to have 2 significant digits in it because I know that 3.2 only has 2 significant digits. Now, if it doesn't matter if it's reversed, if it's in the other order, no matter what, your answer will have the same number of significant digits as the number you're multiplying or dividing that has the least number. So I hope I cleared some things up for you today. In how to split a Reese's Peanut Butter Cup, and how to calculate significant digits. On assignment for N2N Studios, I'm Sierra Fox. Back to you, Alice.